Have you ever seen a poll in the news and wondered what that whole plus or minus 3% thing really means? Well, today we're going to demystify the statistics you see every single day, and we're going to do it by solving a real world scientific puzzle.
So, to really get a handle on margin of error, our story actually starts not in a newsroom, but way out on a coral reef, with this beautiful but kind of vulnerable creature, the sea fan. These right here are sea fans, and they're not just pretty, they're absolutely vital to the health of our oceans. But on a reef off the Yucatan Peninsula, scientists noticed that a whole lot of them were getting sick with a disease called aspergillosis. They really needed to figure out just how bad is this problem.
To find out, they did what scientists do. They took a random sample. At one reef, they checked out 104 sea fans and found that 54 of them were infected, which, if you do the math, gives us this super specific number, 51.9%.
And right here, this is the big question, isn't it? Can we really truly say that exactly 51.9% of all the sea fans on that entire reef are sick? Or is this number just, well, a clue, a hint at a much larger truth?
Well, the answer is we can't just take that 51.9% as the absolute truth. And that's because of a little thing called sampling variability. We need a better tool. We need to build, of all things, a net.
I mean, think about it, right? If the researchers went back the next day and took another random sample of 104 sea fans, do you think they'd find exactly 54 infected ones again? Almost no chance. They might find 52 or maybe 58. Every single sample is a little bit different. So our 51.9%? It's just an estimate. So instead of putting all our faith in that one single number, we build an interval around it. The best way to picture it is like you're casting a net. You can't point to the exact spot where the fish is, but you can be pretty darn confident it's somewhere inside your net. And this net is what statisticians call a confidence interval. And the size of that net? Well, that's determined by the margin of error. It's simply how far we decide to reach out from our sample number, that 51.9%, to create our range of believable values.
And this is the simple but really powerful idea at the heart of it all. To create our net, we just take our best guess from the sample, that's our estimate, and then we just add and subtract the margin of error on either side. That's it. You see this phrase all the time, 95% confident. It is by far the most common level of confidence used in science, in polling, everywhere. But what does it actually mean? Because, and this is important, it doesn't mean there's a 95% probability the true value is inside our one specific net. It's a little more clever than that. So let's just stick with our net analogy for a second. Imagine we could go out to that reef and take 20 different random samples, and for each one, we build a brand new 95% confidence interval. So we're casting 20 different nets. The 95% confidence part isn't about any single net. It's about the method we're using to make the nets. It means that if we were to do this over and over, 95% of the nets we create, so on average, 19 out of 20, would successfully catch the true infection rate for the entire reef. And this right here perfectly captures the uncertainty of it all. About 5% of the time, or one time out of 20, we're just going to get an unlucky sample. Our net is going to miss the true value completely. Now, here's the kicker. We only have one net, the one from our single sample. We're 95% confident that our net is one of the winners, but we can never be 100% sure. So let's go back to our sea fans. When we actually calculate the 95% confidence interval for our sample, this is the net we did. We are 95% confident that the true actual proportion of infected sea fans on that entire reef is somewhere between 42.1% and 61.7%. Okay, so this brings us to a really crucial trade-off in pretty much all of statistics. The thing is, you can't have perfect certainty and perfect precision at the same time. You always have to choose. Just look at this comparison. If we want to be more confident, let's say we want to be 99% confident, we have to cast a wider net. That makes us more certain we've caught the true value, sure, but it gives us a much less precise estimate of where it is. It's a balancing act. I mean, a net that goes from 0% to 100% is 100% certain to be right, but it's also completely useless. All right, so we have our net, we get the trade-offs. Now let's take this whole idea out of the ocean and apply it to something you see constantly, news headlines. Here's a real-world example for you. A Fox News poll from back in 2007 surveyed 900 registered voters. It found that 82% said they believe that global warming exists.
Now, just like with the CFANs, that 82% is our estimate from the sample. And there it is, that familiar little phrase. This plus or minus 3% is the exact same thing we've been talking about this whole time. It's the size of the net. It means they created a 95% confidence interval that stretches from 79% on the low end to 85% on the high end. That's the margin of error you see in the news. So, the crucial point is, knowing this makes you a much, much smarter consumer of data. You can now look right past the headline number and actually understand the uncertainty that's hiding behind it. So here's what to look for. But you gotta be a little careful, because this whole method only works if a few key conditions are met. First, the sample absolutely has to be random. If it's not, it's biased, and the results are worthless. Second, the sample needs to be big enough to be reliable. A good rule of thumb is you want at least 10 successes and 10 failures. And finally, to make sure all the math works out, the sample shouldn't be more than 10% of the total population. So just keep those things in the back of your mind when you see a poll. And that really is the big takeaway here. The whole goal of statistics isn't to give us one single certain answer. That's almost always impossible. The real goal is to measure our uncertainty, to put a number on it, and to be totally upfront about it. The margin of error? It's really just a tool for honesty. So the next time a poll flashes on your screen with a big number and a little margin of error, I hope you see more than just the number. I hope you see the estimate sitting there in the middle, the margin of error stretching out on both sides, and that invisible net that it creates. A net cast in a huge ocean of data, giving us our best possible glimpse of the truth.